Hi students, welcome to Abhyaas IIT Prep. In this video, we're going to solve some questions on matrices and determinants. These are previous year questions. So we are starting with phase 1 that happened on January. So we are going by shift wise. Okay, the given question is, consider the matrix f of x equals to cos x minus sin x 0, sin x cos x 0, 0, 0, 1. Given below are two statements. Statement 1, f of minus x is the inverse of matrix f of x. F of x into f of y equal to f of x plus y. In the light of the above statements, choose the correct answer for the options given below. So we have to check whether these statements are true or false. Whenever we see inverse of a matrix, we tend to find the matrix. But here it will be time taking. To find the inverse of a matrix, you have to find the cofactors adjoint A and determinant A. Okay, if the matrix is simple like this, it is okay, but if it is complex, like if we have values here, it will be difficult. So for this only, we have a property that is A into A inverse equals to identity, right? And A inverse into A equals to identity. Say if A inverse is given and A is given, we multiply these two matrices and we get the identity. We can say that A inverse is the inverse of matrix here, right? So we find this. Given f of minus x is the inverse of f of x. So if we multiply f of x and f of minus x and we get identity, then we can say for sure that f of minus x is the inverse of f of x. So f of x is cos x minus sin x 0, sin x cos x 0, 0, 0, 1. This is f of x, and f of minus x will be cos minus x, which is cos x, minus sin of minus x, which is sin x. For your understanding only, I have written that. Okay, so 0 minus sin x, sin minus x is minus sin x, cos minus x is cos x, 0, 0, 0, 1. Okay, now for multiplying matrices, we have to go row and column. So row cos x, cos square x plus sin square x plus 0, that will be 1. Cos x sin x minus sin x cos x 0, 0, 0, 0. Now sin x cos x minus sin x cos x and 0, sin square x plus cos square x plus 0, that is 1, sin x 0, 0, 0 and 0, 0, 0. This also 0, 0, 0 and this will be 1. Okay, 0, 0, 1. So we get the identity. So f of minus x is the inverse of f of x. This statement is true. Now the second statement, f of x into f of y equal to f of x plus y. Second statement is f of x into f of y equal to f of x plus y. So consider f of x, that is this only. So I am writing f of y, cos y minus sin y 0, sin y cos y 0, 0, 0, 1. Multiplying cos x cos y, we get cos x cos y minus sin x sin y and plus 0. So we are not writing 0. The second value will be cos x minus sin y, so and minus sin x cos y. Next 0, 0, 0. Next sin x cos y, cos x sin y. Sin x cos y plus cos x sin y plus 0. Then again minus sin x sin y, cos x cos y, minus sin x sin y plus cos x cos y 0. The below values will be 0, 0, 1, 0, 0, 0, 0, 0, 1. So 0, 0, 1. Okay. Now we know the formula for sin A plus B, which is sin A cos B, sin A cos B plus cos A sin B. So this can be written as sin X plus Y. Okay, and cos A plus B is cos A cos B minus sin A sin B. So this is cos X plus Y. Here if we take minus, common minus, then sin X cos Y plus cos X sin Y, which is minus sin X plus Y. Here also cos A cos B minus sin A sin B, which is cos X plus Y. Okay, the other values are 0, 1. So statement 2 also holds true. So this is also true. So the given option will be both statement 1 and statement 2 are true. Okay, we'll move to the next question. Okay, let A equals to 201, 110, 101, B equals to B1, B2, B3, where B1, B2, B3 are column matrices. Okay, and AB1 equals to column matrix, AB2 equal to column matrix, AB3 is also column matrix. If alpha is equal to data of B and beta is the sum of all diagonal elements of B. So if in order to find B, we have to find B1, B2, B3, then we can do the det, then we will have alpha, and beta is the sum of all diagonal elements. So sum of diagonal elements is trace, so beta is equals to trace of B. Okay, then we have to find alpha cube plus beta cube. Okay, so given A is this, so AB1 will be A matrix into some B1 matrix, let's say x1, y1, z1, that gives 1, 0, 0. Okay, A matrix is 201, 110, 101. Multiplying we get 2x1 plus 0y1 plus z1. Okay, then x1 plus y1 plus 0, x1 plus y1 plus 0, and x1 plus 0 plus z1, x1 plus z1 is equal to how much? 1, 0, 0. Since these are corresponding elements, 2x1 plus z1 equals to 1, x1 plus y1 equals to 0, that implies x1 equals to minus y1, and x1 plus z1 equals to 0, so x1 equals to minus z1. Okay, taking this, substituting here, we will get minus 2z1 plus z1 equals to 1, minus 2z1 plus z1 equals to 1, so z1 equals to minus 1. So z1 equals to minus 1, that implies 1 is equals to, x1 is equals to 1, y1 equals to minus 1, and z1 equals to minus 1. Okay, so we'll write the matrix here. We'll write the B1 matrix here. So B1 equals to 1, minus 1, minus 1. Similarly, we have to find B2 and B3, then we can write the B matrix. The B matrix, here the first column is this, minus 1, minus 1. So we have to find another two columns by doing the same exact things. Okay, let's do that. So then I'll erase this. After finding B, I will erase this. Okay, next AB2 equals to 230. So 201, 110, 101, 101 into x2, y2, z2 is equals to how much? 230. 230. Now similarly, multiplying we get 2x1, 2x2. Yeah, 2x2 plus z2 is equals to 2. Then x2 plus y2 is equals to 3. And x2 plus z2 equal to 0. So from here we will get x2 is equals to minus z2. Again substituting this here, that will be minus 2z2 plus z2 minus z2 is equals to 2. So z2 will be minus 2. Z2 will be minus 2. X2 will be 2. Substituting here, y2 will be 3 minus 2, that is 1. So 2, 1 minus 2. 2, 1 minus 2. Again, for the third matrix. Okay. AB3 is equal to 3 to 1. So 2, 0, 1, 1, 1, 0, 1, 0, 1 into x3, y3, z3 is equals to 3 to 1, right? 3 to 1. Okay. Again multiplying 2x3 plus z3 is equals to 3. x3 plus y3 is equals to 2. x3 plus z3 is equals to 1. Okay. Since x3 plus z3 equals to 1, if we substitute here 2x3 plus z3, take one x3 away, x3 plus 1 is equals to 3. That implies x3 is equals to 2. Okay. Substituting 2 here, y3 will be 0. Substituting here, z3 is equals to 2 minus 1 minus 2, right? Minus 1. Okay. Okay, all good. So that is 2, 0, minus 1. Now we get the B matrix. Now we have to find alpha, that is mod B. So alpha is equals to mod B is equals to 1 into minus 1 minus 2 into 1 plus 2 into 2 plus 1, that is 3. Okay. Minus 1 minus 2 minus 3 plus 6 minus 3 plus 6, that equal to 3. So we got alpha as 3. Okay. Now beta. Beta is the sum of all diagonal elements. So beta is equal to sum of all diagonal elements, that is trace B. That is 1, 1 minus 1. 1 plus 1 minus 1 equals to 1. So beta is equal to 1, alpha is equal to 3. Now alpha cube plus beta cube. Alpha cube plus beta cube. That is 27 plus 1, 28. Okay. So 28 is our answer. Okay. Next question. Next question. The values of alpha for which det equal to 0 lie in the interval. So we have to open the determinant. So let's open the determinant. 1 into 0 minus 3 alpha plus 1 into alpha plus 1 by 3 minus 3 by 2 into 0 minus 2 alpha plus 3 into alpha plus 1 by 3 plus alpha plus 3 by 2 into 3 alpha plus 1 minus 1 by 3 into 2 alpha plus 3. Okay. So that will be minus 3 alpha square minus 3 alpha square minus alpha minus 1 by 3 plus 2 alpha square plus 2 alpha by 3 plus 3 alpha plus 1. Okay. Plus alpha plus 3 by 2 into 3 alpha minus 2 alpha by 3. Yeah, that's it. So this will be minus 3 alpha square minus 2 alpha minus 1 by 3 plus 3 alpha square plus alpha plus 9 alpha by 2 plus 3 by 2 plus this is how much? 7 alpha by 3. Okay, 7 alpha square by 3 plus 7 alpha by 2. Okay, now this equals to, this gets cancelled, we have 7 alpha square by 3 there, and minus 2 alpha plus alpha, so minus alpha. This also, now 9 alpha by 2 plus 7 alpha by 2, that is 16 alpha by 2, minus 1 by 3 plus 3 by 2, so minus 1 by 3 plus 3 by 2, 6, 7 plus 7 by 6. Okay, so determinant equal to 0, it is given equal to 0. Oh. So equal to 0. Now 7 alpha square by 3 minus 8, right? So minus 7 alpha, no, plus 7 alpha, plus 7 by 6 equal to 0. Removing 7, we get 2 alpha square plus 6 alpha plus 1 equal to 0. Taking LCM, we got this. So this thing doesn't have factors, so we will do the D formula, that is alpha is equals to minus b plus or minus root b square minus 4ac. Okay, so root b square is 36 minus 4 to 8. Okay, by 2a, that is 4. So 36 minus 8 minus 6 plus or minus root 28 by 4. So 28 we can write as 14 2s, 7 4s. So minus 6 plus or minus 2 root 7 by 4. That equals to minus 3 plus or minus root 7 by 2. Okay. Root 7 value will be after 4, right? And before 9. So this will be 2 point something. Okay, let's say 2.6, let's say. So that equals to minus 3 plus or minus 2.6 by 2. So adding we will get minus 0.4 by 2, which is near to 0. Minus 0. How much? 0.2. Okay. And the next value will be adding this. So we will get subtracting minus 5.6 by 2, that equals to minus 2.8 something. So we are around minus to minus. So the extreme values are there. In this interval, okay, 0, minus 3. This value satisfies the answer. So, okay. Okay, next, moving on to the next question. Then the sum of the diagonal elements of matrix A square is what? Okay. Is how much? We have to find the value. So let A be a real matrix. Say A is equals to AB, CD. And X is an identity matrix, and det of A minus Xi equal to 0. So A minus Xi equal to 0. Since A is this, we know identity 1001. A, B, C, D minus X into I, that will be X0, 0X. We have to take a det for this, and this is 0. So that implies A minus X, B, C, D minus X, det equal to 0. Now opening the det, we get A minus X into B, D minus X minus BC equal to 0. That implies AD plus X square minus X, if we take common multiplying, we get A plus D minus BC equal to 0. So that is X square. I will write here only. x square minus x into a plus d plus ad minus bc equal to 0. So this is in the form of ax square plus bx plus c equal to 0. So whenever a quadratic equation is given, we can, and the roots are here, okay. So when roots are given, we know the sum of the roots x1 plus x2 equals to minus b by a, and product of roots x1 x2 equals to c by a, okay. So minus 1 plus 3 is 2, which is minus b by a, minus b, so that will be a plus d by a, that is 1. Oh, minus 1 plus 3, okay. I've done my writing. So minus 1 plus 3, 2 equals to a plus. So a plus d is 2. Now minus 1 into 3, that will be minus 3 is equal to c by a, ad minus bc by 1, ad minus bc. Okay, now we got the two values. Now then the sum of the diagonal elements of matrix A square. So A square, we have to find A square and then we have to proceed the trace of A square. So ABCD into ABCD. A square plus BC, AB plus BD. Now CA plus DC and CB plus D square. Okay, here given sum of diagonal elements, that is trace of A square. So trace of A square is A square plus BC plus okay, CB plus D square equal to how much? We can write this as A square plus D square, right? We have A plus D, so we will use A plus D whole square minus 2AD, and we have 2BC here, so plus 2BC. That implies A plus D value is how much? 2. It will be 4. Okay. Okay. AD minus BC. We have AD minus BC. Here we have BC minus AD. So we'll take minus. So that equals to. We have taken minus common. So 9 plus 6 plus 4, 10. We got 10 as the answer. Okay. Now let's move on to the next question. Let A be a square matrix such that A into A transpose equal to identity. Then half of A into A plus A transpose whole square plus. Okay, good. We have given this. If we are expanding this, okay, actually this is simple question only. You have to expand this. Half A into A plus B whole square is how much? A square plus B square plus 2AB. When the values are given, we write 2AB. Here it is A into A transpose plus A transpose into A. Actually, we have a direct formula, A plus B whole square plus A minus B whole square equals to 2A square plus B square. But I wanted to explain about this. In matrices, we are multiplying two different matrices. We know AB not equals to BA. So we can't write this as 2 into A, 2A transpose, but here it is given like that. So let's leave it. And this will be A square plus A transpose whole square minus A into A transpose minus A transpose into A. So I said A plus B whole square plus A minus B whole square equals to 2 into A square plus B square. So these things get cancelled and we get half A into 2 A square plus A transpose whole square. Okay, 2 gets cancelled, that will be A cube plus A into A transpose whole square. That equal to A cube plus A into A transpose into A transpose. This is identity given, that equals to A cube plus A transpose. So it's a simple answer. Next question. Okay, let A equals to 1 0 0 0 alpha beta and 0 beta alpha, and mod 2A whole cube equals to 2 power 21. Okay, where alpha beta belongs to integers, then the value of alpha is. So yeah, now we have a property k mod A equals to k det A equals to k power n det A, where A is an n by n square order matrix. So we have to use this property. Whenever you are reading about properties, try to solve a simple example so you can understand why the property is given like that. So I will be using that. Mod 2A is equals to, I am taking this for now. So that will be, this is 8 mod A, right? Okay. Now, given 8 mod A whole cube is equals to 2 power 21. So that equals to 2 cube mod A cube is equals to 2 power 21. This is 2 power 9. Removing 2 power 9 from here, we will get 12. So mod A cube is equals to 2 power 12. Removing 3, we have to cube root. So mod A is equals to 2 power 4. 2 power 4 is 16. Okay, so mod A is equal to 16. A is given, so mod A will be, det A will be 1 into alpha square minus beta square. Okay, so alpha square minus beta square equal to 16. This implies alpha plus beta into alpha minus beta is equal to 16. Okay, we have to find values for alpha. Okay, we have to find the value of alpha only. Okay, finding the factors for 16. 16 into 1, 8 into 2, 4 into 4. We have to find two values such that some of them will be here and difference of them will also be here. Okay, if we say 0 comma 4, take 0 comma 4, 0 plus 4 or 0 minus 4, it will be 16. 4 plus 0, 4 minus 0, 16. Okay, this can be done. 8, 2. Yeah, if we take 5 comma 3, 5 plus 3 is 8, 5 minus 3 is 2. Okay, so this will also come. So for alpha, we can take 4 or 5. Okay, since beta is less here, if 3 minus 5 will be minus 2, right? So we'll get minus 16. So thinking, we confirmed alpha can be 4 or 5. So from the given option, 2. Okay, next question. Let A is equals to 2, 1, 2, 6, 2, 11, 3, 3, 2 and P is equals to 1, 2, 0, 5, 0, 2, 7, 1, 5. Sum of prime factors of P inverse A, P minus 2i. Okay, determinant of, okay. If we started finding P inverse that equals to adjoint P by det P, it will take time. It will consume too much of your time. So again, we have to use the property. We know P inverse P is equals to I equals to P into P inverse. Here he given P inverse and P, so I took the P. Normally we write A inverse into A. So taking P as P inverse into P, because P inverse P, right? So mod P inverse AP minus 2 P inverse P. Taking P inverse common, AP minus 2P mod. We can take, we can take P also common here. So that will be a minus 2i. Why I? Because this is a matrix, not values. So that will be 2i. We have a property where a b mod is equals to mod a into mod b. Right? So by applying this, we will get P inverse mod a minus 2i mod p. Okay. This is a thing you have to know. P inverse p is equals to I. Mod is equal to, this is also a property. So mod p inverse mod p is equals to 1. Det value of I is equal to 1, right? So P and P inverse are inversely proportional. So these values get cancelled out. So we have to find only a minus 2i mod. So a minus 2i, that will be 2 minus 0, 2 minus 2, 0, 1, 2 minus 0, 2, 6 minus 0, 2 minus 0, 2 minus 2, 11 minus 0, 11, 3 minus 0, 3 minus 0, 2 minus 2, 0. Okay. We are doing determinant, right? So we have to find the determinant value of 0, 1, 2, 6, 0, 11, 3, 3, 0. That equals to 0 into minus 1 into 0 into anything 0 minus 1 into 0 minus 33 plus 2 into 18 minus 0. 18 minus 0. So plus 33 plus 36, that equal to 69. Nice. So the answer is 69. Is it divisible by 2? No. It can be divisible by 3. That is 3 times 23. Now, is that 23 is a prime number? So sum of primes is 23 plus 3, 26. So answer is 26. Okay. Moving on to the next question. Let for any 3 distinct consecutive terms a, b, c of an AP, the lines ax plus by plus c equal to 0 be concurrent at point P. Okay, given lines at point P and q alpha beta be a point that the system of equations has infinitely many solutions. Okay. So to be infinitely many solutions, we need delta or det equal to 0 and one of delta 1, delta 2 and delta 3 should be 0. Okay. So given consecutive terms ABC in AP, right? If ABC are in AP, we get 2B is equals to A plus C. Yeah, that implies A minus 2B plus C is equal to 0. I have written it like this because given the lines, not the line, the lines. Okay, so it is given system of lines. Comparing with that, ax plus by plus c is equals to 0. This system of lines are passing through a point, that is P. So comparing, we get x equal to 1 and y is equals to minus 2. So this will be the point 1 comma minus 2 where these lines are being concurrent. Okay, point P. Many lines are which are in the form of ax plus by plus c equal to 0 are going through the point P 1 comma minus 2 and Q be a point such that, okay, now we have to find Q. So delta equal to 0, that is 1 1 1 2 5 alpha 1 2 3 equal to 0. So 15 minus 2 alpha minus 6 minus alpha plus 4 minus 5 equal to 0. 15 minus 2 alpha plus alpha minus alpha. 15 minus 6. 4 minus 5 is minus 1. Minus 7. 15 minus 7 plus 8 is equal to 0. That implies alpha is equals to 8. Okay. Now to find beta value, beta is here, so we have to find either delta 1, delta 2, delta 3. Let's see. I'm taking delta 3 because alpha is there, but we got the alpha value. I'll be removing it. So 116 delta 3. This is delta 3, guys. So 116, 25 beta, 25 beta, and 123. Sorry, 124. This should be 0, right? This should be 0. Now 5 4s, 20 minus 2 beta minus 8 minus beta plus 6 into 4 minus 5 minus 1 equal to 0. So 20 minus 8, 12. 12 minus 6, 6 minus 2 beta plus beta minus beta equal to 0. So beta is equal to 6. We got the values of alpha beta, that is 8, 6. So Q alpha beta is the point given, that is 8, 6. Now distance PQ square. So PQ formula is root x2 minus x1 whole square. So PQ square will be x2 minus x1 whole square plus y2 minus y1 whole square. 8, 1. So that will be 7. 8 minus 1 whole square, right? So 7 square 49 plus 6 minus 2, 8. So 64. 49 plus 64 will be 113. So the answer is 113. Okay. Okay. Next question. So next question, if f of x equals to this, then 1 by 5 f dash of 0 is equals to. Okay, if you observe, here we have cos power 4x everywhere, sin power 4x everywhere, and sin square 2x. So if we subtract these values, then it will be easy for us. So f of x will be, I'm doing row operations, R2 implies R2 minus R1 and R3 implies R3 minus R1. Okay, so we will get 2 cos power 4x, 2 sin power 4x, 3 plus 2 sin square 2x. Oh, sorry, determinant pal. 3 plus 2 cos power 4x minus, so 3, 0, minus 3, 0, 3, and minus 3. If we open this determinant, we will get f of x is equals to 2 cos power 4x into plus 9 minus 2 sin power 4x into minus 9. Okay, plus 3 plus 2 sin square 2x. No, 3 plus 3 plus sin square 2x. 3 plus sin square 2x into 9. So we will get f of x as 18. F of x equals to 18 cos power 4x plus 18 sin power 4x. Okay, 9 3 is 27 plus 27 and 9 sin square 2x. Okay, we can further reduce it, but let's do the differentiation part. So f dash of x equals to 18 4 cos cube x into minus sin x plus 4 sin cube x into cos x plus 0 plus 9 into 2 sin 2x into cos 2x into 2. Okay, so f dash of x will be okay, 18 into 4, 36, 72. 72 sin cube x cos x minus sin x cos cube x plus 9 to 18. We can write this as sine 4x. So 18 sine 4x. Okay. Now we need to find the value of f dash of 0. Let's substitute x equal to 0 here. So 72 into 0 into 1 minus 0 into 1. So this is 0 plus 18 into sine 0, 0. So we got f dash of 0 equal to 0. So 1 by 5 f dash of 0 will be 0. Okay guys. So to the next question. Consider the system of linear equation x plus y plus z equal to 4 mu and x plus 2y plus 2 mu z equal to 10 mu, x plus 3y plus 4 lambda square z equals to mu square plus 15. Which of the following statements is not correct? So we have to check which statement is not correct. 1 1 1 1 2 2 lambda 1 3 4 lambda square is equals to 4 mu 10 mu square plus 15. Okay. Now we have to check which statement is not correct. So let's try to check. Yeah. Okay. So let's take that equal to 0. If we get the value for lambda, we have to check whether what values are happening. So let's take that equal to 0. We get 1 into 8 lambda square minus 6 lambda minus 4 lambda square minus 2 lambda plus 1 into 3 minus 2, that will be 1, equal to 0. So 8 lambda square 5 minus 4 lambda square, 4 lambda square minus 6 plus 2 minus 4 lambda plus 1 equal to 0. So this can be written as 1 minus 2 lambda whole square equal to 0 or 2 lambda minus 1 whole square equal to 0. So we get lambda is equals to 1 by 2. Okay. So if lambda equals to 1 by 2, we'll get that equal to 0, which is inconsistent. For infinite solutions, we have to check delta 1, delta 2, delta 3 also. So if delta not equal to 1 by 2, it will be consistent also. Okay. So let's check for delta 1 or delta 2. So I'm taking delta 3 directly. It will be easy. Delta 3 equal to 0. 1 1 1. No, 1 to 4 mu. 1 to 10 mu. And 1 3 mu square plus 15 equal to 0. So 1 into 2 mu square plus 30 minus 30 mu minus 1 into mu square plus 15 minus 10 mu plus 4 mu into 3 minus 2 1 equal to 0. 2 mu square plus 30 minus 30 mu minus mu square minus 15 plus 10 mu plus 4 mu equal to 0. So mu square 30 10 minus 20 plus 4 minus 16 mu. So 30 minus 15, that will be minus 15 plus 15 equal to 0. So for mu we will get mu minus 1 into mu minus 15 equal to 0. So mu can be either 1 or 15. So let's check the statements. Okay, so the lambda value is 1 by 2 and mu value is 1 comma 15. Let's check the options. So for lambda not equal to 1 by 2, and mu not equal to 1 comma 15, we will get unique solutions. Probably because if lambda equal to 1 by 2, then we will get det equal to 0, right? So it shouldn't be 1 by 2 to be consistent. So this is true, and yeah, this is also true. System is consistent for lambda not equal to 1 by 2. Okay, for lambda equal to 1 by 2, lambda equal to 1 by 2 and mu equal to 15, there will be infinite solutions. We just did that. So this is the wrong options. So there we have it. Okay. So moving on to the next question. Yeah, this is also same type question. So I want you guys to try this. So for such more content on IIT Prep, subscribe to our channel. Please like, share and comment. Thank you.